Hello guys, now I am going to talk about Montreal Olympics complex case study. It is the main stadium for 1976 Olympics. It is built for many facilities like bicycle events, swimming pools, swimming events, and many sporting events can be held in that main stadium. And the total expected cost of the entire Olympic complex is 120 million, but it ran over to 1.5 billion, which is nearly 10 to 15 times of expected. And there are many reasons for this spillover of cost, like besides inflation, there are other problems like design problems and planning problems, estimation problems, and etc. So now we are going to look at each and every problem detailedly. First of all, going to design problems. Like the design was very ultra modern and dramatic in concept. Like the top view of stadium will look like an elliptical seashell with a handle, but due to overrun of cost, they have cut down the most part of it, and they deleted the cover part. You can see the stadium at the top. Like they have deleted the cover part at first, and it resulted in a top roof which is inclined. And to get the pillar free space, they have introduced complex ribs instead of pillars. Like as the top view of the stadium is inclined, these ribs are not of same height, which led to difficult situation in assembling and aligning. And one more thing, the constructibility was not at all considered during the design, and the post tension design feature which is used in this structure was one of the problem. Like in winter, water entered into these tubes and it got frozen, and removal of this water became very expensive. And they have constructed viaduct with a very complex design instead of directly constructing it. So it increased the cost to about 15 times of that viaduct. Next, coming to resource shortages. As the city is hosting Olympics, like there are heavy construction activities going on in that area, which has exhausted all the local resources of materials, labor, equipment, etc. Like then they went to outside labor and importing of construction equipment and materials. Like it led to very high cost of transportation, which again led to increase in prices and overall budget of the project. And these imported materials are of very high cost, and lease prices are also very high for equipment. And coming to labor issues, nearly 80 days were lost to strike because the labor went on strike, because it has the project has features like fixed deadline and scarcity of resources. So labor took it as an advantage and went to strikes, which nearly 80 days were lost. And even there was a situation like at the like nearly 2 months before the start of Olympics, there was slowdown of work by electricians and plumbers, like which resulted in Olympic Organization Committee had delayed the turnover of project by 6 days. And like they have increased resources and labor resource, but which resulted in crowding working space, which in turn does not increase the productivity to the required scale. It is also one of the problem. And there are other problems like they have used epoxy glued and post tension members that is new to North American contractors. So they have to learn the process. So it had led to very waste of time and expensive also. And the weather in the city is also one of the major problem. Like winter months were mostly unproductive, and the cost of heating measures were it also increases the cost. And one more important thing is during construction planning, while making critical path network, it was made by the people who are unfamiliar with the real world construction activities. Like while they are developing this critical path network, it was did like most of the activities were allocated simultaneously, so that resources and labor cannot be accommodated between these. and there is delay in planning process which was started 2 years late, and inflation is one of the major project as the duration of project was also exceeded, and the inflation rate in addition to that inflation rate reached double digits. So it created add-on effect, so which increased the cost much, and there was poor client engineering contract relationships. Like there was a change in client in between. The project was handed over to other authority that led to poor relations between them, and actually the design process was carried out by a French design and engineering firm. There was a mismatch between dimensioning units, like they have to convert the dimensions. That also led to a problem, and all these results, like at the end when the stadium has started, the cost per seat is $13,000. Like we can see that everything went wrong in this project. Like there are like problems related to labor, resources, constructability, design, everything went wrong. And like these are some suggestions. Like first of all, cost estimation. They had neglected the they have underestimated the rate of inflation and rate of materials and some of the things. Like design process, we can't construct the very complicated designs. Like it should be kept in concern while designing, and materials has to be chosen by keeping local weather conditions and availability in mind. Like they have imported several materials from neighboring countries, and they have used post-tensioned members which where the water entered and it got frozen. It also became a problem. So we have to choose the materials such that keeping these factors in mind, and a proper agreements to be made with labor regarding strike. It was not made, so which eventually lead to delay of project, and strict deadlines are to be followed, of course. And we have to avoid crowding. Like we can't increase the resources like that, productivity decreases, and proper planning should be done, which is not done. I mean it is delayed in this case, and proper client engineering contracts should be maintained. And these are some of the suggestions. That's it. Thank you.
I'm from Group 8, and the project is like Project from Hell. It's basically to build a corporate campus in the outskirts, suburbs of Chennai. The client is Infotech Construct. So they are like a software firm, so they couldn't, they hired other consultants to build this one. Then they took 2 architects from Uruguay, and the design was basically to like a bird's eye view, which resembles a butterfly with a center spine. So the project was planned in 2 phases. Phase 1 with 3 office buildings, central spine and some general services. Phase 2, the other 3 office buildings, customer briefing tower and other general services. Timeline was like to project the start in January 2006, and then finish the first building by 2007 April, and then within 2 months the second building, and within 2 months the third building. But even by the end of November, the first building itself is not completed. So the people involved were like engineering consultants, the site team from the Infotech consultant itself, and then project management consultants and nominated subcontractors. The main contractor in phase 1 was Nation Builders. EC was aligned tasked with scheduling, drawings, other works, and then nominated subcontractors took care of other works, electrical, mechanical and interior. So the nominated subcontractors were nominated by the client itself. So the contractor was not happy with it, like why shouldn't I involve so that I could coordinate with them well. But so that the coordination was not well between the contractor and subcontractors. Then even at the end of the delay, like the project was delayed by around 7 months. Then the contractor took a delay analysis and claimed only 45 days were because of them, and the other delays were with because of non-subcontractors. So the risks involved were like, it was a complex design, so the workers were not familiar with the work and they had to figure out how to do that, and it made, it caused delays. And there was also like productivity was less and constructability also was less. Next, architect from architect's point of view, it was like foreign architect. So during construction of superstructure, there was frequent rains. So there shafts were like leading to the basement area. So it was frequently flooded. This was an issue because of the foreign architects. Drawings, there were like many changes made according to the plans, and the schedule has to be updated again and again. So there was a delay because of that. Procurement risks. Resources were like some are obtained from foreign countries, so there were delays in procuring that. So they couldn't do the work that was scheduled that day. And labor was like, because the construction site was away from the city, they couldn't, villages near that area couldn't allocate the enough labor, and the prominent, normal laborers cannot go till there, like they are not willing to go. So at every point of time there was only 50% of labor available. Construction risks, it was like, the client will be, since the delay is going on, client will say like, okay, we will move the deadline before. Contractor will say okay, but it will be as usual, there will be delays. So, and there will be miscommunication between the contractor and the client. Amount of rework, yeah, there was no optimal sequencing, like for example, there was a handrail and steel work going on. First they put the handrail, and then for the superstructure they had to do the welding work. So the handrail was damaged after doing that, and again they had to do the work again. This was like back of sequencing. And then climate and rains caused productivity to decrease. Welding was done at a lower place. There were last minute delays. The client was client got to know the details about last minute. Then there was no clear documentation on why the delays occurred. So the client was like, it was due to the inefficiency of the project management consultant. So in the second building, they were like, they planned an in-house project management system. So primarily they will take care of the management itself. Then to mitigate the risks that were in the first building, they are like using this similar drawings for building 1 and building 2, and the construction methods also were quite similar. Material was already procured along with the material for first building. So there was some risk mitigated, but they do face other risks like obtaining labor and equipment. There was no coordination between the contractor and the subcontractor, and that's it. NCs, their underperformance was due to like market dynamics. There were a lot of projects going on at that time, so they were like, already this project is delayed, so there are high risks. Why to concentrate on this project? We can concentrate on other projects and gain some profits. So that was one reason for them.
What we've looked at are two projects where the construction has gone horribly wrong, right? So in the Montreal case, as these guys were saying, what was it, 120 million went to 1.5 billion. These are not small numbers, right? It's huge, right? And just imagine if that happens, if you think back to a few classes, your whole financial analysis, right, is done based on some cost and some revenue, right? So you've assumed a certain cost, you've assumed a certain revenue stream, you've discounted it, etc., and you've come up with some IRR of internal rate of return of 15% or whatever it is. Now imagine if your costs increase tenfold, right? That's the end of the project. Like, I mean, you're definitely never going to make any kind of profit, right, if you have these kinds of projects, right? So construction risks are very large and they can really affect the fundamental economics of the project, okay? So the question then is, from the two cases that we've looked at, so we've mentioned, both presenters have mentioned specific risks, right? I mean, specific problems. This was a challenge here, that was a challenge. But what, according to you, are some risk categories that come out when you're doing construction? What are some categories of risks? Alright, so design risk, what is design risk? Okay. So one of the big risks is that designs keep on changing, right? Why do they keep on changing? Because clients obviously have requirements. It's very difficult for you to think of things right at the beginning. So over a period of time, very often clients also can't picture what a facility will look like. Only when it starts coming up do they actually start realizing that this is what we want, and it happens everywhere in our own academic complexes, this, that, everywhere. So there are changes. Now what happens with changes is that cost might increase, but I might have to go get more resources, things get delayed, right? So there are certain risks that the design might not be complete, okay? And again, we'll talk about solutions later on, but this is where theoretically 3D BIM models and so on can play a role, right? So you can simulate 3D, you can do walkthroughs, and we can sort of arrive on what the building should look like much ahead of time, rather than having the client see it midway and say, wow, this is what I want. I want this change, okay? So that's one sort of category of risk. Any other category, Harsh? What is safety risk? Okay, so safety again is a big risk in construction, because you are dealing with a lot of heavy machinery, a lot of heavy and very sharp implements. There are all kinds of, there are places where you can just fall off. There are reinforcing steel bars that you can get impaled on. So lots of risks, large equipment that can literally crush you. So safety is a big risk during the construction phase, and safety, if you don't pay enough attention to safety, it might actually cost you a lot of money, right? Because every time there is an accident, there is an injury, there is a direct cost, right? If a worker gets injured, then perhaps you have to pay their family or them. If they get killed, then the amount you pay is higher. But also there is a loss of productivity, right? Imagine it's a group of 5 laborers working, 1 or 2 of them are injured, there's a loss in productivity. You bring a new person in, that person might not gel with the team. Morale is lowered, right? Think about it, the person next to you just got his foot chopped off, could have been you. Right. So, how excited are you to come and work productively, right? So, safety risks have economic consequences in terms of cost and time, okay? So, that's another category of risk. Just staying with design for a second, what other kinds of design risks design related risks we see on the cases? Yeah. 1 second, let's one by one, let's go. Alexander first. Such as? Okay, so I'm going to give it a new term which I was going to put up anyway. It's called constructibility, which is, it's clearly I want something iconic, right? So both of these projects were iconic, right? Montreal Olympics, you're making a statement to the world. Was also an organization that wanted an iconic building, okay? Because you're iconic, you want things that may never have been done in that area before. You might want building materials that might not be it might not exist in India, that need to be imported. You might want facades, right, shapes and so on, which are very difficult to construct, right? And sometimes these then lead to extra costs and and time. As we all know, if you want me to sort of pour a concrete wall, it's relatively easy. I get formwork, I pour it. If you want me to pour a curved surface, it's a bit more difficult. I've got to create the formwork, I've got to make sure the concrete flows, all of that, and that takes a little bit more time and effort, right? So constructibility, I think, is a set of risks to look at. Something that came out in the Montreal, what else came out in the Montreal case? Why was the scheduling really bad? Okay. Yeah. So, and again, this is an issue, right? Because all of these projects are heavily time bound, right? The Olympics, for instance, obviously the Olympic dates are announced years in advance, right? And unlike any other facility where you can say, yeah, please come back, I'll delay it by 3 months. You can't tell all the athletes in the world that, sorry, we're not having the Olympics now, come back 3 months later, right? So those are all set in stone. And if you don't give yourself enough time to plan, right, then essentially you've got very little time to actually come up with designs, with cost estimates, with schedules. And when you have very little time, you often end up doing a shoddy job, right? Even in the second case, if you look at the timeline, right? The timeline was barely 16 months or 18 months, right? So from 2006 April or something up till 2007, that's a very short amount of time to develop something of the complexity that you wanted to develop. Did the case have a picture? Did it have a figure? It was not there in the case, okay, then I can circulate a copy of the picture, right, but it's a very complex undertaking, and because you don't have enough time, these risks start exacerbating. So again, there's a clear risk mitigation measure there, right. So take more time in planning this out. For instance, what do we, Rio Olympics was what, 2 years ago, right, 2016. We already know who's in 2020, we already know 2024, right. Do we know 2028 yet? Probably not, but this far ahead of time, and by the way, the winners of the 2024 Olympics were known a couple of years ago. So you have a long lead time, right? No point planning for it 2 years before the games, right? You really need to start planning for these much ahead of time. Similarly with these corporate facilities, right? So I think essentially there is a lot to be done in terms of timing, okay? But here again, one of the issues that comes up is to what extent is design and construction collaborating, because this could actually save time, right? If construction could tell design, what your, so design in both these cases there are international architects, right? They've been called in because they want to create something iconic. They want to create something iconic because it's going to go on their resume, right? They're going to show all of these pictures tomorrow of this stadium I built in Barbados, right? This office building I built in Chennai, etc., right? So they have an incentive to design something that's extremely complex. Okay, they also have an incentive to design something that's extremely complex because normally their fee is a percentage of the total cost of the structure, which means the more complex and the more expensive it is, the more I get paid. Okay, so that's fine. But the point is, and there's nothing wrong in expecting something that is unique, and that's sort of, if you're visionary, go ahead. But at the same time, you've got time and cost implications, right? And if you just left architects have a free hand, you'll end up with something that's probably extremely complex and extremely costly. Okay, but if you bring contractors in, contractors are the exact opposite, right? The more complex it is, the more difficult it is for me to construct, right? And therefore, I might be able to actually have a discussion saying, look, these aspects, can you really make these a bit more normal so I can construct them faster, whereas, certain facades, etc., you can actually make much more unique. So I think if design and construction end up talking to each other, construction again has a very good idea of what's possible with regards to schedule, because they know how long things take. Right, they understand the kinds of resources that they might have. They might understand the practical challenges on site. So very often the fact that design and construction don't talk to each other, right, is a big issue here. Another issue, I mean there are many issues, but another issue here was the weather, which I think is very important. So Canada is really cold, right? You can't build all year round. And I've made this point again. I was consulting on a project once in Mumbai, where this large developer was going to build this big tower. Residential apartments, etc., and they were going to start construction in June, right? So what happens in Mumbai in June? It rains, right? And of course it rains heavily, right? So the question is, if you're going to excavate, right, are you building luxury apartments or are you building a swimming pool, right? Because you're not going to be able to work. You're just going to fill up this excavated area with water. You'll have to dewater, etc. So I think all of these are considerations that will lead to cost and time overruns. So I think there are a lot of things that can go wrong in construction. We haven't even talked about labor, which came up in the case, labor strikes. We haven't talked about resources, material shortage. Yeah, unavailability of material resources, unavailability of machinery, right? Metro rail is struggling because you don't have enough tunnel boring machines available to build the tunnels the way you want them, right? So you have to wait a little bit for one stretch to be completed before you can start another stretch, and so on and so forth, right? So there are all of these challenges that make it very difficult to build on time, right? So essentially you've got to do a couple of things, right? One is you've got to try to figure out how you mitigate risk, and one way of mitigating risk is getting design and construction to talk to each other, right? That sort of helps mitigate risk a little bit. So essentially another way of looking at it is you can look at the contract, okay, and you can try to put things into the contract. Yes, there are a few, right? Larsen and Toubro, for instance, does both design and construction. There's a certain form of contract called a design and build contract, where you go to somebody and say, you design it and build it for me, right? Turnkey contract, as people call them. So there are some firms across the world, but by and large the industry tends to be specialized. So particularly in India, you don't have that many, of these kinds of players. You have a handful of people who can both design and build, right? Although people say we can design and build, very often they are doing a joint venture with somebody for design or for build, right? But it is possible, okay? So one way is to go to the contract, and through the contract have mechanisms. So contracts, for instance, have things called price escalation clauses, okay? For no fault of my own, the price of steel is increased by 10%, right? So can we do something about it, okay? But also you will have to think non-contractually, right? We'll have to sort of think how can the client, the contractor, the designer all be involved in decision making, right? So that these projects don't have the kinds of cost and time overruns. So it's somebody's responsibility to tell the client, it's great if you want your building to look like a butterfly or a dragonfly or whatever it was from, you know, when an aircraft flies overhead. It's not even on the flight path, right? I don't know if anyone's ever seen the butterfly shape, but anyway, this is, but the point is it's going to, you either have to budget more time and more money and then you work out your economics in that fashion, or if you want something in 16 months, this is what can be done. Right, and unless you have that kind of constructive dialogue, which today does not happen because the client puts a sack of money in the ground and says, I want a facility in 16 months, right? The architect says, sure, you know, here's a pretty picture, get a contractor to build it for you, right? Contractors are under pressure to get business, so they outcompete everyone, they want to get projects, and sooner or later you're in the kind of mess that Montreal faced during the Olympics or these guys faced. And by the way, you can think of, you know, if you want sort of a Montrealish example, think Commonwealth Games. Right, Commonwealth Games was very, very similar, right? Rishi, you had your hand up and then we'll wind up in a minute. So, did they underbid for it? So, see, the Olympic bid has nothing to do with the money, right? To get the Olympic bid, you are essentially showing proof that you can host the Olympics. So, that has nothing to do with whether you bid 120 million or 500 million, right? That's something you do internally. Oh, you mean, so did they go back internally to their finance department and say, allow us to bid for the Montreal Olympics because it only cost 120 million? Maybe there might be an element of that in it, because if they had gone in and said it's going to cost 1.5 billion, you know, Canada would have said, look, forget it, right? We'll do it 30 years down the line. Yeah, it's called the Boston Big Dig. It's sort of been a, yeah, it was one of those, I mean, there's a lot of literature you can read on the Big Dig in the, on the web, which I would encourage you to do, but a classic example of overruns. So, some of these infrastructure projects in the Big Dig, what happens is once you, it's like a metro rail, right? Once you build 5 kilometers of tunnel, doesn't make sense to stop the project because what you've built is wasted, right? So, sometimes there's this motivation to say, look, you know, let's keep going. People talk about it as putting good money after bad, alright, but there are all kinds of dynamics. But I think the point here is that your infrastructure costs come down to the asset costs in many of these large cases. The road projects economics are driven by the cost of construction of the road. Right, the power plant's economics are driven by the cost of construction of the power plant. To the extent that you don't understand that there are these risks and you let the project go out of hand, you can have 100, you know, 1000% cost overruns, right? And then your project is in huge trouble, right? So, construction risks are very real, there are all kinds of risks, design, safety, constructability, schedule, weather, labor, etc. And we have got to figure out either decisioneering wise or managerially how we are going to manage those risks, right? Either you are going to bring people together, you are going to allocate the risk to somebody else, bring in new technology, use building information modeling, right? You really need to think about these risks, otherwise these projects go haywire. There is data, and we will get back to it a bit later in the semester, that, and I think maybe Swapnika, was it in your presentation or somebody else's presentation I saw today where, no sorry, it was in an earlier session, 9 out of 10 projects typically run over budget. Right, 9 out of 10 infrastructure projects, that's a large percentage, right. So, this is a very real risk, okay, and we have just seen some of these risks. We will talk again a little bit later on how to mitigate them, okay. Just one note on the Vadodara Halol case, there is some data. I would like you guys to do some numerical analysis, right, don't just sort of qualitatively look at the case, they have got some traffic data, right, try to play with those numbers a little bit, and when you come and present, you know, justify, right, a little bit rather than just wave your hands around, okay. Alright, see you all